Alright, so today's goal is to solve a nomenclature question that shows up pretty much every single year. It is naming a mixed, straight chain cycloalkane kind of species. So the conditions for this naming are you have a alkane, no double bonds, no triple bonds, no functional groups, but you have a mix between a branched component and a cyclic component. So I'll just throw these rules up here. They're not going to make much sense right now, but there's no use building up to them because usually with nomenclature, everything is a little bit arbitrary. So I recommend you pause the video, copy these down, and then we're going to use them as we go through some exercises. So I'll do the first one. All right, so say we have a species that looks like this. So this is a mixed cycloalkane and a regular alkane. So we got a branched component and we have a cyclic component. So the first thing we want to do is, step one is we want to identify the possible parent chains that we have. So by that I mean you could either name this as a cyclobutane or you can name this as a butane. So really the possible parent chains are the cyclic component or the longest chain in the branched component. So step two, it says, is choose the one with more substituents. So if we name this as a cyclobutane, we only have one substituent, and if we name this as a butane, we have two substituents. See that this is one substituent, that's two substituents, and over here, just this chain over here is one substituent. So we name this as the one with more substituents. So we're going to name it as a butane. So we'll continue on with this. The third part of our strategy says, name the substituents. So we want to name this and we want to name this. Well, this is rather simple because we know this is just a simple cyclobutyl group and this is a methyl group. So we've now named the substituents. All right, the next thing we need to do is we need to number our longest chain. So are we going to go 1, 2, 3, 4, or are we going to go 1, 2, 3, 4? Are we going left to right or right to left? Now remember, the way you do this is the first point of substitution. So over here, if we start here, our first point of substitution is 1. If we start here, our first point of substitution is 2. Knowing that, we're going left to right. And finally, what we have to do is we have to combine all this together to make our name. So we know that the parent chain is a butane, so that's going to go in the back. Then we name each of the substituents and arrange them in alphabetical order with their numbering. So since C comes before M, we go 1-cyclobutyl. Make sure you don't put butane because this is a group now, and a 3-methyl butane. All right, this is a simpler one. Let's try one that's a little bit more difficult. And I recommend, at this point, you pause the video and give it a shot. Okay, I'm going to assume that you tried it out. So the first thing is step one once again. Do we name this as a cyclohexane or do we name this as a butane? Well, once again, we need to look at the number of substituents. This guy is going to have one substituent, just that branched chain over there, and the butane over here is going to have two substituents, this and this. So once again, we see that we have more substituents coming off the butane than the cyclohexane. Once again, we need to look at this substrate here and name each of these groups. This is a methyl group, this is a cyclohexyl group. So now that we've named these, we should look at how the numbering works. So here you'll see that 1, 2, 3, 4, we have a substituent on 2, and over here we have 1, 2, 3, 4, a substituent on 2. So we have a tie going this way and a tie going this way. The way you decide the tie, if you look at our rules up here, is when we're talking about naming the substituents, it's going to be alphabetical order. So alphabetically, what comes first, cyclohexyl or methyl? You'll see that the C in cyclohexyl makes it so that shows up first, that breaks the tie. So we prefer this way with the 2 going to cyclohexyl instead of the 2 going to methyl. And finally, all you need to do is arrange the name. You know that butane is going to go in the back. You do 2-cyclohexyl, 3-methyl, and make sure you get those alphabetically in the same order that they appeared. Luckily, we already decided the tie, so we already know the order. So it's going to be this. Okay, let's try yet another one. So this time, more shapes. All right, and give it a try yourself. Okay, I'm going to assume you tried it. The first thing we need to do, once again, is identify our possible parent chains. So we can name this as a cyclobutane, we can name this as a propane, or we can name this as a cyclopentane. To decide that, we need to figure out which one has the greatest number of substituents. Here, the cyclobutane would have 1, this entire part of the molecule over here. This propane would have 2, this, and this cyclopentane would only have 1 substituent. So it's going to look like this. So we're going to name it as a propane. But the next thing you need to do is you need to decide the name of these 2 substituents. That's rather easy. You know the one on the left is a cyclobutyl group and the one on the right is a cyclopentyl group. But once again, if we're numbering this, which is our next step, we could go 1, 2, 3 or 1, 2, 3. At both points of this numbering, you have a substitution at the first carbon. So again, you need to break the tie by using alphabetical order. Here we have a cyclobutyl and here we have a cyclopentyl, so the B beats the P. So in that tie, the butyl wins, so we go 1, 2, 3 from right to left, and then once again, we need to arrange the remaining parts of the name in alphabetical order. So propane is the parent chain, that'll go in the back. So our final name will look like this. All right, another example. Again, getting more and more complicated as we go along. Let's take a look at this. All right, give it a shot yourself. Okay, so once again, we need to decide how we're going to name this, either as a cyclohexane derivative or the straight chain. So it turns out that if you look at this, it has 2 substituents, 1, 2, and if you look at this, it has 2 substituents. So we have a tie. The way that we break the tie is that we say the longer chain wins. So here we have a chain of 6, 1, 2, 3, 4, 5, 6, and here we have a chain of 1, 2, 3, 4, 5, 6, 7, 8, 9. So the 9 wins. We're going to name this as the straight chain. Well, I should list that they both have 2 substituents. That's why we have that tie. All right, so naming the straight chain, the next thing we need to do is we need to figure out the names of each of these substituents. So hopefully you've memorized these groups. If we're going to use a common name for the bottom, which if you remember from our rules, we want to prefer using common names if possible on these substituents, then you'll realize that this is a neopentyl group down here. Now again, I can't really coach you on how to recognize this. You really just have to go in your book, look up the table where they have all of these common name prefixes, and memorize the shapes of these. So that's like isobutyl, isopropyl, all those sorts of things. Just know those off the bat. Here we could do a little bit of work. So when you have a more complicated sort of substituent that you can't use a common name for, you basically name it as its own molecule. So we know the point of attachment, that's what I'm trying to demonstrate here, is going to be 1. So if this was a completely different molecule, we had to name this, we could call it a cyclohexane, and since this point of attachment, the main chain already determines its number, we know it's going to be 1, 2, 3, 4. It's going to be a 4-methyl cyclohexane, but because it's still a group substituent part of this molecule, we're going to give it a cyclohexyl, not a cyclohexane. So finally, step 4 is determine the numbering, and here 1, 2, 3, 4 we hit our first point of substitution, 1, 2, 3, 4, 5 we hit our first point of substitution, so left to right wins. It's going to look like this. So now that you've done this, simply glue all your parts together. You know the parent chain's a nonane, that's going to go in the back. Then you just arrange each of these substituents with their numbers. So notice here, the M comes before the N, Don't forget that. All right. Yeah, another problem. Let's try, as they get more and more complicated, is this. Let me get some space. All right, give this a shot yourself. All right, I'm going to assume you tried it. Once again, identify possible parent chains. It's either going to be this straight chain over here or this cyclic part over here. This has one substituent, this has two substituents, so this wins. We're going to name it as a cyclopentane. So the next thing we need to do is we need to, once again, name the groups. So this one up here is easy, you know, that's simply a methyl group, but over here we have no common name for this attachment over here. So we have to do what we did before, where we name it basically as its own molecule, with the numbering given as if 1 is where it's attached. So that means that the longest chain we can run, if we start here at 1, is 4, so it's going to be a 1-ethyl-butyl. If this is alone, you call it a 1-ethyl-butane, but it isn't, it's part of a larger molecule, so we have to use that butyl instead of butane. Okay, once again, the problem here when you're numbering, which is our next step, is you have 1, 2 or 1, 2. How do you know which way to go around this ring? Well, you need to use alphabetical order. So the E beats the M, so you start here and you go around this way. So 1, 2. And lastly, combine all of these together and your final name will be this. 1-ethyl-butyl, 2-methyl-cyclopentane. Okay. Go one last one, which is sort of the most complicated of all. Try naming this. Pause the video and give it a shot. Alright, I'm gonna assume you tried it. The good part here, at least, is these ring substituents are symmetric, so you could either name it as a cyclobutane or as a longest chain molecule. And if you look at the cyclobutane, there's 2 substituents, and if you look at the straight chain, there's 3. 1, 2, 3. So we're going to name it as the straight chain molecule. Okay, so the next thing we need to do is, once again, we need to name those substituents. This one over here to the right is easy, but we have to name this one to the, I guess, top and bottom separately. Once again, you treat the point of attachment, if we're looking down here, as 1. We go around this ring, we call it a 3-methyl-cyclobutyl. And then, once again, we need to determine the numbering here. It's going to be easy since you can see right to left, your second point of attachment, well, your point of attachment is on 2, so that's going to be favored. So you're looking at something like this, and then you glue all the pieces together in the way that you usually do. You know it's a heptane, so that's going to be in the back, and your final answer is going to be this somewhat complicated 4,4-di-3-methyl-cyclobutyl 2-methylheptane. And remember, these 4's go before the 2 because of alphabetical order. Because this C, well, yeah. All right, hopefully that clears some things up for you guys. Good luck. You're going to have one of these questions probably on your first